Hello, I'm Lee. In this video, we're going to explore more usage of const in C++. So let's first look at this declaration. This is something we're very familiar about. So by declaring a variable as const, you can only give it an initial value, and later on you cannot change the value of that var. Alright, so you see the regular variable, you can change the value of that variable later on, but const, you can't. So that's something we are familiar with. How about when pointer is involved, what const means? So let's take a look at this pointer. We declare it as const int star. And since it's a pointer, so we give it an address of a integer. So we give it address of a number, and remember, number isn't const. So we give the address of number to this int pointer. So what does that one mean when you put const before that one? That means you cannot modify the memory this int pointer points to. So when you try to dereference int pointer and modify that memory, it won't compile. It says illegal. So you see that memory is modifiable, but not through this pointer. You can imagine this pointer as a constant handle to that memory. You can modify that memory through other pointers or through this number name, but you cannot modify it through this pointer, this int pointer. So that's what const means here. You cannot modify the memory it points to. So now let's take a look at the second format. This time, int pointer 2, it's still a pointer to an integer. When I put const before this pointer name and give the address of number there, you see I can modify that memory it points to, but I cannot modify the pointer itself. So when you put const before the pointer name, that just means this pointer cannot be modified. So unlike this one, that means the memory it points to cannot be modified. Alright, so how about when we put both const? That just means both. So that means you cannot modify this memory through int pointer 3, and you cannot modify int pointer 3 to make it point to somewhere else. So you see, you cannot modify the memory it points to, and you cannot modify the pointer itself. Alright, so that's the two format of const when pointer is involved. So let's take a look at this one. How about when we give the address to int pointer, we know that this int pointer is constant. That means you cannot modify the memory it points to. And how about let's put this address of this var. This var, remember this var, what's this var? This constant integer. That means you shouldn't modify that memory. So we can put the address of a constant variable to a constant pointer. Remember, int pointer says I'm not going to modify the memory I point to. But this is illegal, and this is illegal too. Because think about it, when you give the address of a constant memory to a regular pointer, that means later on you can modify that memory through this pointer. No, that's illegal. And similarly, you cannot give a constant pointer to a regular pointer, because if you do this assignment, later on you can modify that memory. Alright, so what if you really want to do that? If you really want to do that, remember C++ offers typecasting. So int pointer is a constant pointer, which means you cannot modify the memory it points to. So how about let's cast it to a regular int pointer and assign it to a regular int pointer, then later on do the dereference. This will compile, but the result of this one is undefined. So totally depends on the compiler. So we don't really know what's going on there. So please stay away from this method, because when you do the casting, you violate. It allow you to do that, but the result is undefined. And when you really need to do the casting and you know what you're doing, you know what's happening later, so you better do some more specific casting, not that general casting. This casting is, remember you learned static cast, and later on we will see dynamic cast, and this is called const cast. Const cast only cast off the constness, so it's more specific. It doesn't touch any other things. It just cast off the constness. So here we cast off the constness and then reference it, but still the result is undefined. All right, so now we see more about constness when pointer is involved. Thank you.